and I'm going to introduce myself a little bit. So I studied in Politecnico di Milano with Marco. After Politecnico, I mean, during Politecnico, I've done like Erasmus program at KTH. And then after Politecnico, went in research, doing research at MIT, specifically in machine learning and artificial intelligence applied to supply chain. And then I joined McKinsey. I've been there for 2 years and a half, working with Walter, working with Alessandro. And after McKinsey, I moved to back to MIT for a master, done some projects for Coca-Cola, so went in Mexico in the meantime. And after Mexico, I just moved in Silicon Valley and end-to-end analytics, where I'm now. So the journey didn't finish there, didn't stop there, in the sense that while I'm working in end-to-end analytics, is becoming more and more present Orientami, that is a startup launched in Italy. So this is a bit my background. What is end-to-end analytics? End-to-end analytics is a company that basically puts together the world of consulting together with the world of advanced analytics, machine learning and optimization. There are, I mean, a PhD from Stanford, MIT, Harvard that went working there. And as I got to know them, I really wanted to deepen how optimization and machine learning were supporting supply chain, that I would say is a specialty there. So this is the company started like 15 years ago, and this is the company that I'm in now. So I have these slides in Italian, but I'm going to speak in English. So in particular, I just want to give you an overview. I mean, you know, probably even better than me what's happening around there. It's a big crisis that is affecting all of us and is affecting also the companies. Okay, in particular, we want to make sure to support the companies that are facing this problem. And now approach. The one is to react to what's happening. The other one is to innovate. And the difference is really like between a reaction and innovation is that once you like decide that you want to innovate, you are going to change internal processes and you are going to embed also like technical solutions to be like more prepared even for anything that could happen in the future. And in this, the combination of machine learning and optimization helps a lot. So what are the main problems that the companies are facing? So there are three main problems when we speak about supply chain. So the first one is the demand. The demand is extremely variable, highly variable, right? So this is also because like variability of the export, but even like the local demand is extremely variable in any industry. Then the second problem is really like the behaviors of consumers, right? So the consumers are going more and more towards the e-commerce and local deliveries. So it's important to have a structure, a cost structure that help us to optimize that. And then the third problem is the supply. So there are a lot of risks in the supply since the actual situation, and we need to reduce this risk. And then the very last problem is basically employees that work in the companies is related to more to HR problems. Like so, I would tell you about these specifically these 6 use cases that are going to help us facing the problems that we saw before. So the idea is that I'm going very fast to these use cases, and then we open to questions so that we can have some interaction. Maybe there are questions like technical questions, more technical questions about these use cases, then we're going to deepen them. So the first one is demand forecasting. Okay, so the problem of demand forecasting is that, as I said, forecasting in all the industries is changing a lot, and it's extremely important to have a solution that helps us to predict demand, but to predict demand while capturing signals that are weak. Okay, so like the idea is to have embedded in the processes, in our processes, models that can run, can be updated as frequently as possible in order to capture the last signals and to use what's happening now in order to predict the future. So now, something that I wanted to say about this use case is that it's there is one of the biggest bread makers of the world we work with, Fora, and the idea is that they really increase their sales by 50%, but then we need to understand when this curve will go back to normality. Or another use case, like is I work. This is not confidential, so I work together with Humanitas in a no-profit project. And what they wanted to know, for example, is the demand of bed. In this case, is the demand of a product that is related to healthcare. In their case, it's bed occupancy. So they wanted to predict, given the curves of COVID that we see, what was gonna be the requirements for beds. So like we gave them KPIs to look at in order to predict the peak that actually happened. Okay, so they could be ready before. So machine learning here is extremely critical, both in industries related to healthcare and in industry related to other, I mean, not strictly related to healthcare, exactly. The second use case is really like promotion optimization. And promotion optimization is one of the most sold use cases at this point in time in CPG, in retail. Why is that? It is that companies invest a lot in promotions, but they don't know the ROI. They don't know what's the return on investment out of these promotions. And now that they actually have, in a few industries, a lot of stock in the warehouses, they really like struggle and understand what's the best promotion in order to keep not too low margins, but still sell what they have in the warehouses. They don't know. Like usually companies in Italy as well, but even here in Silicon Valley, I mean, even this is not confidential, worked for Google on a project that was on promotion optimization. And really like the point was to understand how price, promotion, and all the other factors were going to impact the demand. Because then like what you can do is that once you have a machine learning model that connects like causes with effect, so like price, promotion, characteristics of the customers, of the location you're selling the product in, and the effect that is the demand, once you have a machine learning that connects these two, then actually you can build heuristics or even like genetic algorithms, optimization algorithms on top. You consider this link between cause and effect as an input of the optimization model. And then you'll say, okay, now I want to maximize the revenues or maximize the profit, let's say, given that I have this relationship between promotion and sales, and therefore decision variable is promotion. And for like the model, like knowing the link between promotion and sales, knowing what he has to maximize, is going to define the optimal point for promotion. So another use case that is like very important in this time is like the risk along the supply chain. Like it's important to evaluate the risk among the supply chain. So in this case, for example, if we consider variability of lead time being a factor of risk, then one use case is going to predict the variability of the lead time. And for example, what's the standard deviation of it? Or what's the curve of it? So that you can be prepared for different scenarios. But again, companies are not used to this kind of approach, usually. I mean, then it depends on the industry, obviously. Then another use case is production schedule optimization. I'm actually at the moment working on a project that is related to this. And this is really like super focused on optimization. So what we are going to do here in this case is to maximize the production given a lot of constraints. And I'll tell you later like how this kind of problems is faced from a more technical point of view. But this again, a very, like it's a huge requirement now in COVID time, because a lot of companies need to close production lines. So once you close a production line, you need to understand what to do in the other production lines, how to, let's say, decide what product you are going to produce at what time in the production lines that you have still open. In a way, you were not used to operate. So you don't know how to maximize the efficiency of the production lines that you kept open. And actually, I mean, this is happening in all the industries where the demand is decreasing a lot. They need to close production lines and they need to be super efficient in the production lines they still have open. So again, this is an optimization problem. This is huge. I mean, this other one, the inventory optimization, is a huge problem in the sense that people, because of the variability of the demand, they need to be sure they have stock, such as they don't go out of stock. At the same time, they don't have, I mean, a lot of overstock, right? But we have like these classical formulas that, I mean, I'm sure that most of you know of safety stock, okay? Now, something that is very important is that there are two factors multiplied for this formula. The first one is the service level you want to have for the client. So what's the probability you want to have stock in the warehouse is related to that probability. And then like you have a sigma, and the sigma depends on the lead time, the variability of the lead time, demand, and so on. So now this formula can be complex, can be much more complex in the sense that how do you know what's the variability of the lead time? In order to know the variability of the lead time itself, you need a forecasting model. Or for example, how do you know what's the demand? In order to know the demand, you need a forecasting model. So like, I mean, this is a formula that people in supply chain, like all of them know, not even in the field, but like, then how are you going to define all these parameters? Then for the definition of each parameter, there is actually machine learning model behind, right? And or even for the definition of what's the optimal service level, in this case, it's not a machine learning usually model, it's more optimization model. Why is that? Because you need to optimize for the, again, the profits, right? So the higher is the margin of a product, the higher is the safety stock you want to keep in. And the higher is the cost of production, the lower is the safety stock you want to keep in. So it's a trade-off. How to solve this trade-off, again, is an optimization model. There is, like, in literature, it's called the news vendor problem. Now, the last use case I wanted to present is this routing optimization. So now e-commerce is going crazy. Amazon is losing a lot of market share, not because their e-commerce is decreasing, but just because the general, like, market of e-commerce is increasing the volumes. So how do we equip for this? How do companies equip for this? It's extremely important that I mean the structure of cost being the same, the structure of cost, we can maximize the volumes that we are transferring, and we can go, like, to the houses of people. So the problem is no more going to just warehouses. This problem is how to reach the houses of people, keeping the cost of transportation not too high, because, I mean, obviously, like, I cannot just devote a truck to deliver something in my house. I need to combine the volumes around me, and I need to combine volumes around me in an optimized way. So again, this is from a technical point of view, from a literature point of view, extremely complex model of optimization, but is extremely useful for companies, especially in this moment of COVID, where the demand in e-commerce is growing. So in the last 10 minutes, I just want to show you, like, this slide that is actually a formulation of a simple optimization model. And this is just the only slide with formulas. And what we have here is a typical optimization model that now you see, like, formalized this way on paper. Actually, you can translate it very easily in Python with the Gurabi engine behind. For example, Gurabi is a solver. And so what's happening here in this optimization model? I wanted to show you this optimization model because just showing use cases might seem a bit abstract. I mean, a bit, like, fluffy. So in this case, this is what's behind most of the use cases I showed before. And an optimization model starts by defining a objective function. Okay. In this case, we have the minimization of production, transportation, delays, and I mean, this is some of different locations, different activities, different freight methods, and then, like, it's very important for optimization model to have constraints that actually replicate what's happening in the reality. So there is a first constraint where we have a demand. Okay, demand is defined given a product and a destination. Okay, so you find the index as PD. It means, like, demand is defined by product and destination. And then there is a multiplier that actually is a percentage. And you need to make sure that actually the sales are meeting the demand. So the sales by product, destination, freight method, site are meeting the overall demand times a percentage defined by the same dimensions as the sales. So the idea here, in a simple way, is what you sell granularly in different, like from different sites, is actually summing up to your total demand. Now, then, like what you need to define is the fact that is the production, right? So this is the production, the definition of production, and here the production activity is basically defined given a product, an activity, and a site. Then you have other constraints. So the other constraints, actually, this is very connected to what I was saying before. So the sum of the sales should be equal to the demand, okay? And this is very important. The market share is, let's say, 0. So sorry, I start from this variable that is open, yes or not. That actually is the decision variable. Open yes or no is like equal to 1 when a site is open, equal to 0 when a site is not open. Okay, and this is a decision variable that the model is going to define. So the entire problem is actually to define this, is to define if, in this case, a site is going to be open or not in order to satisfy specific demand. Okay, so this is very important. I just want to repeat this, like this model specifically is to decide if a site should be open or not, given that I want to meet demand. Open or not is included in this variable, open S, okay? Obviously, if it's not open, then open S goes to 0, but it means that even demand share goes to 0, so I cannot satisfy any kind of percentage of demand from this site. If it's equal to 1, this might go from 0 to 1. So this percentage might be greater than 0. So, and then like the same it's here, right? So if the site is not open, then the production, then here on the right side of the equation goes to 0. Left side, that is our production, needs to go to 0. Instead, if open is 1, then we can have a capacity of the site, and then production can be at max equal to the capacity. So optimization models like mixed integer linear programming, all this kind of optimization model are very beautiful because there is a logic behind of if else that you need to translate in equations, okay, like these ones, okay, in formulas like these ones. And so like sometimes like you spend a lot of time thinking maybe things are more complex than this. I mean, it's very simple. So like how do I translate these if else statements in formulas? Right? And so like you need to translate the entire logic of business in a model using this kind of techniques. If 0, then there must be 0. If 1, then the other variable might be even greater, whatever. So now, where do you start from when you work in a company? No, something that is extremely important here is this. There is a lot of literature at MIT. There is a lot of research in how to integrate this kind of optimization models to machine learning techniques a lot, because like one thing is optimizing on variables that you consider like deterministic, known. Okay. Another thing is optimizing something that you still don't know, that you probably are gonna predict. So in this case, for example, the demand. Okay, the demand. We can like say that here we could put like the average of the last weeks as value of demand, but actually this makes the entire optimization model totally wrong, because it might be like that the accuracy given this our hypothesis is very low. Another approach that I mean is very intuitive is that I'm going to predict the demand first with a machine learning model, and then I'm going to put that prediction in the optimization model. Okay. And a third approach is actually you're going to build 3, 4, 5 different optimization models with different scenarios for the demand. And then like what you're going to do is to minimize the sum of all these optimization models. So like you have one objective function number 1 with demand of scenario number 1. Objective function number 2 with the demand of scenario number 2. Objective function number 3 with the demand scenario number 3. And then what you ask to an optimization model is to minimize objective function number 1 plus 2 plus 3 is another approach. Or like another approach that professor started to experiment is like similar to the last with scenarios, but with the percentages of probability that a specific scenario will occur, right? And then there are like variations on how to mix optimization and machine learning, because actually what's fascinating about mixing optimization and machine learning is that in this case you're not going to optimize what you know. You are going to optimize what it might happen. So you're going to optimize the future. I hope like this like was clear. And again, just to conclude, where should a company start from? Now there are different drivers, right? Feasibility, impact, strategic importance, timing. So it's really like a discussion, an internal discussion of the company to list all these use cases, understand if there are data or not to face them, understand if they are strategically important or not, and then like define exactly like their criteria in order to decide at the end, and going to prioritize according to these dimensions. Now, this is the last slide. What are the takeaways? The takeaways are 3. The first one is it's better to innovate rather than to react, right? The second one is machine learning and optimization help in this COVID time, not only in industries that are related to healthcare, but in all like the industries, because they are all impacted by the situation, the actual situation, as we all know. And then the third one that I think is maybe the most important, we have a huge responsibility. So actually what we can do, like machine learning optimization practitioners, is to provide information, is to provide help in order to make decisions. And this now is extremely important in a lot of industries. So I conclude saying that actually Orientami, that is the startup is actually using a lot of machine learning techniques. It's a startup I started the last month, actually 1 year ago, with Maria Paula. This is an MBA student at Harvard. So it's a program for students that are at the end of the high school in order to help them to define, like, to choose university, right? And it's a tech company. It's not like mentoring. It's really a tech company. So there are we have chatbot that we want to develop. We have machine learning models to embed. And in this case, it's very important to use, in this case of the startup, it's very important to use machine learning in order to help them to let's say broaden their horizons, in the sense that they know, they kind of think that they know what to do, but actually they probably didn't consider other options, right? And one of the machine learning models that we embedded is going to address this problem based on similarities with other students. You are going to propose to these student that we are considering to look at other options that he has. So this is using collaborative filtering, so using the same methodologies that Amazon is using with us to propose other products, or Netflix is using with us to propose, like, videos to see, to watch. So we found, we tested it, students are super happy about it, and we found, like, an incredible value that machine learning can have on society, like even like helping people in their lives, by helping people in their lives. And this is huge. So this is really connected to our last two takeaways. So machine learning is not helpful only on healthcare. In healthcare, it's very important in a lot of situations of personal lives. And we have a huge responsibility. I hope there are questions. I'm aware of the fact that there are just 5 minutes left.